Okay, next we move on to the last part of lipid, which is hydrogenation and interesterification. So these are the learning objectives for this part. So you should be able to illustrate hydrogenation mechanism. Secondly is illustrate interesterification mechanism. And thirdly, explaining factors that affect storage of fats. So we have covered that fats are solid at room temperature, which are high in saturated fatty acid, whereas oil are generally liquid at room temperature and they have low saturated fatty acid content. So unsaturated fat can be converted to saturated fat by process called hydrogenation. Means you are converting oil to fat. Now, what is hydrogenation? Hydrogenation is a chemical process that adds hydrogen to the double bond in the unsaturated fatty acids. So this double bond will be removed so that it becomes saturated. What is the purpose of hydrogenation? It is used to alter lipid or change lipid so they become solid at room temperature. So the triacyl glycerol composition will also be more homogeneous and of course more oxidatively stable, because we know that as the double bond is high in amount, it become less oxidative stable and also less thermally stable. So what is the purpose of hydrogenation besides altering the physical property of liquid oil to solid fat? Another purpose of hydrogenation is to bleach oil. This is the destruction of the double bond in the compound, such as carotenoid, which in turn will cause the oil to lose its color. Now, products that normally produced by hydrogenation process, for example, margarine, shortening, and also partially hydrogenated oil, which have improved oxidative stability when they are partially hydrogenated. So these are the requirements for hydrogenation process. It needs hydrogen gas, catalyst, which is nickel in content 0.01 to 0.02%. Mixing, okay, agitation, so mixing the catalyst and the substrates, in this case is the oil, and the mixing occur from 40 to 60 minutes at high temperature from 250 to 300 degrees Celsius in order for hydrogenation to be a success. So let us look at the mechanism of hydrogenation. So what happened is in step 1, complexation will occur. So complexation is the unsaturated fatty acid will bound to the catalyst at each end of the double bond, okay, followed by step 2, the hydrogenation process itself, where hydrogen break one of the carbon catalyst complex so that it will produce half hydrogenated fatty acid. Okay, The other one, the other hydrogen was, the other carbon will still remain complex to the catalyst. Now, in step 3, complete hydrogenation will occur. So means hydrogen will break the other carbon catalyst bond complex to form fully hydrogenated fatty acid. Now, what happens if there is insufficient supply of hydrogen gas? The fatty acid will be released from the catalyst complex, and the double bond will reform. The drawback of this is that the double bond that reform can be either cis form or trans configuration. Now, when trans configuration is formed, that is the case that is that normally associate with cardiovascular disease. Okay. So this is the mechanism involved in hydrogenation. So first of all, the complexation of the unsaturated fatty acid with the nickel catalyst. So this is the complexation. So nickel catalyst here. Okay. So next comes in the hydrogenation. So hydrogen will break one of these carbon catalyst complex bond, so that it will form half hydrogenated fatty acid here. Okay, but if there is insufficient supply of hydrogen gas, the fatty acid released from the catalyst, and then double bond will reform. Okay, double bond will reform. However, it can reform in the trans configuration. Okay, has the possibility to form into trans configuration, which is related to cardiovascular disease. Okay, not healthy. However, if there is a sufficient supply of hydrogen gas, then we have complete hydrogenated fatty acid. Okay, so the hydrogen, okay, will break the other carbon catalyst complex, and we will get saturated or solid fat. Now, as an exercise, please try to sketch the pathway or the mechanism involved in hydrogenation of oleic acid, given the systematic name is 9-octadecenoic acid, with the numerical abbreviation 18:1. So when we have low hydrogen concentration or low supply of hydrogen gas, it leads to high production of geometric isomer, means the lipid will contain high amount of trans fatty acid, which is associated with increased cardiovascular disease risk. Okay, due to the building up of lipid in the blood vessel. Okay, so the flow, the blood vessel become narrower. Okay, next we move on to interesterification. Now, what is the difference between interesterification and hydrogenation? Hydrogenation is breaking the double bond of the unsaturated fatty acid, but interesterification is exchanging the acyl group among the triglyceride. Okay, so there's no breaking of the double bond. So let's say you have sorry, okay, you have the glycerol here. Okay, so let's say this is the glycerol part, and this is fatty acid 1, fatty acid 2, fatty acid 3, and you have another triglyceride here, okay, with 3 fatty acid. So this fatty acid 1 can exchange with this fatty acid 1 from another triglyceride. So that's what it means by exchange in terms of acid group among the triglyceride. So it can exchange position within, okay, within the triglyceride, or among triglyceride. So among triglyceride or within the triglyceride. So within, it can exchange from fatty acid 1 with fatty acid 3, for example. So that is interesterification. So it is safer because there's no likelihood of formation of trans fatty acid compared to hydrogenation. It has the tendency of forming trans fatty acid if the supply of hydrogen is insufficient. But nowadays, some food manufacturer produces food with only partially hydrogenated, okay, because it is not costly as fully hydrogenated, but still solid fat is formed, okay. So likewise, hydrogenation interesterification will also be different in terms of the physical properties after the interesterification process, okay. For example, the melting profile will also change from the original lipid after it undergoes interesterification. And normally interesterification catalyst used is diacylglycerol anion. So the negative diacylglycerol anion can attack the slightly positive carbonyl group of fatty acid on the triacylglycerol, which form a transition complex, and this transition complex decompose in such a way that the fatty acid is transferred to the diacylglycerol, and the anion will migrate to the site of the transferred fatty acid. So this is the mechanism of interesterification. The negative diacylglycerol anion will attack the slightly positive carbonyl group of the fatty acid, okay, on the triacylglycerol, and then it will form transition complex, okay, and this transition complex decompose where the fatty acid will be transferred. It will be transferred to the diacylglycerol, and the anion will migrate to the site of the transferred fatty acid. So next we move on to storage of fat. How to store fat will depends on its type. For example, fats like butter and margarine are best stored in refrigerator. Remember, I mentioned this in LU1, when you leave butter on your countertop at room temperature after some time, it will produce undesirable smell due to the enzyme activity, okay, lipase, that leads to rancidity of the butter. So that's why it's best stored in the fridge. Shortening and most oil suitable are usually stored at room temperature. However, in tightly covered dark spot on the cupboard shelf. So you put oil inside cupboard, okay, closed cupboard. However, to keep the shortening and oil longer, you refrigerate them. Now, olive oil has shorter shelf life compared to other vegetable oils, and once open, you should refrigerate them. This also due to the inherent stability of the olive oil itself. Remember I mentioned in the previous lecture that olive oil has double bond in it, so it's thermally and oxidatively unstable also. So that's why after opening it's already exposed to oxygen, so you refrigerate to prolong the shelf life. So rancidity is the chemical deterioration of fat which occur when the triglyceride molecule or the fatty acid attached to glycerol are broken down into smaller units, and these broken units leads to off flavor and even undesirable odor. Okay, so this is example just now that I mentioned regarding butter. So there are two basic types of rancidity. The first one is hydrolytic rancidity. Second one is oxidative rancidity. So what is hydrolytic rancidity? So hydrolytic rancidity means the fat become rancid when it exposed to water. Okay, so usually the water is found frozen on the food that is to be fried. So remember the previous lecture I talked about frozen food for deep frying normally will have water content in it, so it can leads to hydrolysis. Okay, hydrolytic rancidity. Second one is oxidative rancidity. This is where fat become rancid when they are exposed to the oxygen in the surrounding air. So this will lead to the formation of hydroperoxide, which in turn decompose into secondary compound, and this secondary compound is the one that is responsible for the rancidity. Okay, and this secondary compound is then converted into tertiary compound, which are free fatty acids.